geographic placement of Delaware presents us with several environmental challenges. These challenges include things such as coastal inundation associated with sea level rise, but also extreme storm events. We also have problems with large precipitation variability from one year to the next. And with our placement in the Mid-Atlantic region of the United States that includes large urban areas and also a lot of agriculture, we have issues both with air pollution and with water pollution.
The motivation for developing nanoscale sensors is to be able to detect toxins in the environment at the lowest levels. As scientists and engineers, we are intrigued by the fact that we can develop nanoscale sensors before they become commercially available. The sensors that we are developing start with a non-woven textile, which we then immerse into a solution of gold nanorods, and they adhere for 12, 24, and 48 hours, with the darkest one being the 48-hour sample. We tailor our sensors for detecting heavy metals in the environment. The first one specifically is copper, which is hazardous to fish. It coats their gills. The second one is mercury, which can be ingested by fish and then becomes hazardous to people. At the sensing stage, we compare a sensor not exposed to mercury with one that is. If the signatures are different, then you know you have the presence of mercury.
A major focus of our research is integrating data from the macro scale, such as our meteorological stations, all the way down to the molecular level, which helps us better understand the chemistry and the biology of what's happening in the water and the soil here in Delaware. The significance of being able to monitor the environment in many different scales really allows us to better solve complex environmental problems that can't be solved by looking at just one of those scales.
Our evolutionary strategy for these nanoscale sensors is twofold. First, we're going to build in some multifunctional capability so as to be able to detect multiple heavy metals in the environment simultaneously. And second, we're going to replace the actual substructure of the sensor with a biodegradable material which is not harmful to the environment.
In addition to collecting data in real time from the macro scale all the way down to the molecular level, our job in this research is to find innovative ways to visualize that data, present that information to government officials who can then use it to make decisions about water quality, emergency management, and other environmental issues that are affecting Delaware.